All right, welcome back. Calculus 1, I wanted to help you do a couple limits analytically. We've been doing a little bit of everything maybe. But now I feel like I'm in 2-3 trying to do some limits analytically, which means that you just try to work it out. You're not going to look at a graph. You're not going to do the numerical thing. You can always do the numerical thing. To me, it's a little bit of a cop-out. As x approaches 2, you could plug in a 1.9 or a 1.9999 or, whatever you feel confident. But then you're just going to get some decimalized answer. Anyway, the way to analytically do these limits is, I told you once before, step one is you plug it in and see what you get. So I started with one of these real boring ones, okay? And I mentioned real boring questions in the last video. Nothing happens here. When you plug in a 2, you just get a y value. The function value at 2 is the same as the limit that as x approaches 2. There's nothing interesting here. But let's just do it. Plug in a 2. That's x squared, so that's 4 times -3. It's -12 plus 5. -12 plus 5 is -7. And I'm finished with that problem. You plug it in, you get an answer. Okay, so the interesting problems, and I did one of these last couple videos back where you plug it in and you get 0 over 0, like this one. Check this out. If you plug in a 3, well, definitely the denominator is a 0. And if you plug in a 3, that's 15 plus 1. The square root of 16 is 4. 4 minus 4 is 0. So this is a different problem. We get this 0 over 0. That's indeterminate. And you don't stop there with these limit questions. You try to fix them. And you can fix them analytically. You can fix them by usually doing some algebra, some kind of algebra. So I did one a couple videos back where we factored it. We canceled that bad factor, and then we could do the limit. This one's a little different. With this square root involved in the problem, I'm going to do an algebraic move called multiply by the conjugate. So here we go. That numerator is the square root. I'm going to multiply by the conjugate of the numerator. That is 5x plus 1 plus 4. So I'm multiplying the numerator by its conjugate. I'm multiplying the denominator by the same thing. That's when you manipulate things algebraically, which is what I'm doing. The legal move is, if you multiply something to the numerator, you got to multiply the same thing in the denominator. In fact, what have I just multiplied here? I've multiplied by a 1. So I haven't altered the value of this expression, but I'm going to change the look of this expression. And here we go. I'm going to try to do the limit as x approaches 3. So I give this advice. Students don't always listen to my advice. You should. My advice is do not FOIL out the denominator. Do not FOIL that denominator. So leave it as x minus 3 in parentheses multiplied by that set of parentheses. But in the numerator, we're going to FOIL it out because that was sort of the point. The conjugate always helps things work out. So when you FOIL this out, it will be this times this. And a square root of 5x plus 1 times the square root of 5x plus 1 is just a 5x plus 1. There will be another term here, positive 4 of those square roots, and then negative 4 of those square roots. So the middle terms cancel. That's what happens with the conjugate. The middle terms cancel as I FOIL it out. The last term is negative 4 times 4, negative 16. So I get the firsts and the lasts, and the outers and the inners canceled each other out. So here I am. Now if I try this limit right now, I think I still got 0 over 0. It still needs a little work here. So let's clean this up a little bit. That numerator is plus 1. That numerator is a 5x minus 15, right? A 1 minus 16. I can factor out a 5. And I'm left with x minus 3. That's perfect, dude. There's an x minus 3 in the denominator. All right, so I got a little sloppy here. One of the things I did is I just started working on my numerator, and I was saving myself some writing. I wasn't writing the denominator. Let's be a little more official here. But I'm going to take those 2 steps I did, and I'm going to write them down here. This is here. I'm still trying to do the limit as x approaches 3, but I cleaned up that numerator. It's 5x minus 15. I factor out the 5. It's 5 times x minus 3, and I'm so happy because now this cancels. And that's what's been giving me that 0 over 0. So now I'm left with this limit. The limit as x approaches 3, and I'm left with a 5 in the numerator and this in the denominator. Square root of 5x plus 1 plus 4. And now I'm going to do the limit, which remember that means plug it in and see what you get. And this time I'll get an answer. I had 0 over 0 I had a problem the whole time until I did this algebraic manipulation and it cleaned it up. It works. Multiplying by the conjugate in a certain situation works. Here we go. Let's finish this. If I plug in the 3, that's 15 plus 1, that's 16. Square root of 16 is 4. 4 plus 4 is 8. This is a 5/8. So that was fun. That was fun. Multiplying by the conjugate is a skill. Factoring is a skill we did in a previous video. I've got another one for you. I'm going to erase this one and do another one. So, way back at the beginning, is there another way you could have done this? I wanted you to do it analytically, and my directions will say do it analytically, so I expect to see this work. But if you're totally struggling and you just want some partial credit, maybe you could figure this out. What would you do? Try to sketch a graph of this and look at it graphically? Maybe, but that might be tough, dude. That might be tough. Would you try to do it numerically? You can always sort of do that. You might not get full credit, not when I say do it analytically, but you could plug in a 2.9999 and try to do the math and see what you'd get. Would you get 5/8? You should get something close to 5/8. Anyway, I'm not going to do that. Let's do another problem here. I want to show you another algebraic technique for doing these tough problems analytically. Here's one. I made up this guy. This is kind of a weird problem. Here comes an x plus 4. So this is a complex fraction. It's got fractions over a fraction, and I'm trying to do the limit as x approaches -4. So, what's step 1 of doing limits? Plug it in and see what you get. Plug it in and see what you get. So we got an answer to that last problem. We'll probably get an answer to this. But if I plug it in, right off the bat I see a 0 in the denominator. And plug it in a -4 plus 7, that's a 1/3 minus, I got a 0 in the numerator. 0 over 0 is indeterminate. Without the limit, what I would say is the function is undefined at -4. The function is undefined, but I'm not trying to, I guess I'm trying to find the y value where it's undefined at. I'm trying to see since it's undefined at -4, let me try to find what's happening really close to -4. Let me try to do this limit. And I can do it analytically. I can get an answer. My advice is to clean this up using algebra. So we've done some factoring and a sum. I did a multiply by the conjugate. That's not applicable here. With these fractions, I think you should get a common denominator. In the numerator, get a common denominator. So here I go, doing a little math. This down here, here's an x plus 4. By the way, I might just call it x plus 4 over 1 for a second. But in that numerator, I want to get a common denominator, which would be a 3 times an x plus 7. And then what do I need to multiply? Oh, okay, he needs to be multiplied by the 3. I need to multiply his numerator by 3. And what does he need? He needs the x plus 7. I got to multiply him by x plus 7. So then I'm subtracting my new numerators there. All right. This limit is still waiting to. I'm going to do this limit when I get a chance. So let's move over here. If you distribute that negative sign there, hang on. If you distribute that negative sign, it's a negative x. And it's a -7 3 minus 7 is a negative 4, so there it is, all over 3 times x minus 7, all over an x plus 4, which is kind of over 1. Just to be technically correct, this limit is still waiting out here. That's what's going on. That's what this equals. The limit equals the limit as x approaches negative 4. That's a negative 4. You know, I think I'll take this. The reason I wrote this as a fraction is so I could multiply by the reciprocal. I'm dividing by x plus 4, but I can flip it up and multiply by the reciprocal 1 over x plus 4. Oh, and that's beautiful. That's going to cancel, but maybe I can't see it unless I factor out a negative sign. Okay, here I go. I got a limit as x goes to negative 4. I'm factoring out a negative sign out of here, a negative 1 out of here. That leaves me with x plus 4 over this 3x minus 7. I'm multiplying by this 1 over x plus 4. And I'm trying to do this limit. This is beautiful. Again, you can definitely see why you're getting that 0 over 0. You're still getting 0 over 0 until you cancel this away. Now you have this problem. The limit as x goes to negative 4 of a negative 1 over a 3 times x minus 7. And now you can do the limit. If you plug in the negative 4, I'm sorry, you know what? I made a mistake. Can you believe it? I finally made a mistake on a video. Hey, I could edit this video. No, hang on. The mistake, did you find it? X plus 7. This is x plus 7. I turned it into an x minus 7. This is an x plus 7. This was an x plus 7. That's what it was. Now, plug in the negative 4. Negative 4 plus 7 is 3. Times 3 is 9. The answer is negative 1/9. That's the answer. We did the limit. It's pretty easy, but I've got to do a lot of algebra. I mean, it's algebra. Everybody's good at algebra, I hope. Especially if you're trying to take calculus, you want to be good at algebra. I knew a guy who said, I didn't even get good at algebra until I took calculus. So calculus is full of these algebraic moves. We need to be able to speak the language, write the language of mathematics, write the language of calculus correctly. And I'm trying to do that for you. So if you could copy what I'm doing, well, not copy, but if you emulate what I'm doing, I think that'll be helpful. So we're doing some tough problems analytically. That was kind of tough. Get a common denominator, multiply by the conjugate. There's more stuff I need to talk about, but I'm going to hit pause on this video.